Okay, so it's 11 o'clock now. I think we'll see the number of attendees start to go up. So welcome to this webinar. We're very pleased to be hosting it today. My name is Nick Ferguson, and I'm a senior manager at Trust IT Services, which was one of the partners in the Hyper AI project, which is of course funded under the Horizon Europe program. Now, part of our role in the Hyper AI project is to build synergies with other EU-funded projects. And today's webinar is an important first step in that objective as we bring together 7 projects which are funded under the same call. Now, what do they have in common? Of course, it's the topic of the Cognitive Computing Continuum. And in a moment, we'll hear more from Emiliano Cora, from the European Commission, and he's a project officer from the European Health and Digital Executive Agency, and also Anne Juan Ferreira, who was policy officer at DG Connect and who was very much involved in designing the call and developing the topics around it. If you can change the slide, Diego, please. So we'll hear from the projects themselves after the presentations from the European Commission. And we'll hear different perspectives and different ways in which these projects are carrying out research and innovating artificial intelligence driven resource management, hyper-distributed computing ecosystems, and applying this to different use cases in different sectors. So actually, applying this to areas where there is a need for better management, better use of data, and in different sectors you'll see as well, such as mobility, health, and manufacturing. So areas in which research can really make an impact, and this impact from research is, of course, very important for the future digital sovereignty of Europe. We'll then be finishing off with a roundtable discussion on topics such as security, interoperability and standards, and also climate considerations with the energy required to run these systems, often in the news at the moment. So you'll also have a chance to ask your questions then when we get to the roundtable at the end. And if you do have questions, can I remind you all to put them into the Q&A box. So there's a chat, so we can keep the chat open, but if you've got a specific question, then add the question to the Q&A and say who it's for, and then our panelists can answer the questions directly. So if you go to the next slide, I'm very pleased to tell you that we have over 100 registrants today, mainly from Europe, of course, and you can see the top countries, nice spread across Northern and Southern Europe. And also, as with any research project, the majority of people following us today are from the research community. So people who are interested in finding more about what the Cognitive Computing Continuum is and the projects which are innovating in this space. So with that, I will hand over to Emiliano and Anna for their introduction on the topic and on the project, and a bit of background as well to why these projects have been funded and their work. So over to you, Emiliano and Anna. Thank you very much.
Thank you, Nicolas. So as Nick said, my name is Emiliano Cora. I work for HADEA, that is the executive agency of the European Commission for Health and Digital Innovation. We are in charge for the implementation of part of Horizon Europe program, and specifically, that's the case of my unit, for the digital cluster of Horizon Europe. That's why today I'm here representing the agency. Also, I'm personally in charge. I'm the project officer for 2 of the projects that will be presented today, that are HyperAI and Swarmchestrate. Other colleagues of mine, I know they are present today also, that are responsible for the other project of the cluster. I would like to welcome you all today here in this webinar. We as European Commission and executive agency, we consider extremely important the development of synergies among European funded projects. So we always welcome initiative like this, where different project comes together, share idea, and try to find common points, common elements on which to cooperate to improve their effort on the topic. So if we can move to the next slide. So I will just briefly introduce HADEA. HADEA is a relatively young agency, has been created in 2021 with the idea to merge the digital and the health topic into the same executive agency to improve synergies. Next slide, please. As I was saying, the agency covered the following topics: so health, food safety, space, industry, and digital. And that we reflect, if we can go to the next slide, on participation and contribution to several programs. But as you can see, Horizon Europe is the main part, let's say, of our effort. Next slide, please. So that will be all from my side. Just to specify that the executive agency HADEA is just the implementation arm of the program. The priority setting and development for the program is developed by our parent Directorate General, that is Connect, that has the responsibility to analyze the policy and research need and to translate them into work program. I will then leave the floor now to my colleague Anna from DG Connect, as she's the policy officer in charge for this topic and can best introduce the topic. Please, Anna, the floor is yours.
Thank you very much, Emiliano, and glad to see that much interest in the workshop today. Just for your background, I am taking over this responsibility from a former colleague of mine that she recently retired, Maria Chacali, that probably she is more familiar to you than myself. So, but happy to be here to present you the objective to which you have applied and won your project. So congratulations first of all on this. So the objective of the Cognitive Computing Continuum, it is basically to this is not the slide I was preparing, but I'm a bit surprised that it is this one. No, if you can go to the very first one. No, the other direction on this one on the background. So this was the first one I intended to have. So the idea of this call, it goes on introducing, on top of the previous work that we have been doing for many years on compute and data management across the edge and cloud, what we have been calling now for years the cloud computing continuum. It was to enable the use of AI in order to handle more optimally this resource and data management. The idea was to bring by employing AI and making the compute continuum, the cognitive compute continuum, to increase the automation and the optimization of this resource and data management, also to enable end-to-end security and the identity management, and to make it more, let's say, optimal in a way, to start using additional kind of data processing resources, which are heterogeneous, that are not the general purpose compute that we have been in the cloud world, cloud and edge world, using for years, CPUs, but also to start opening the door to use GPUs, FPGAs, and other different kind of data processing technologies that are more of interest when we look at how to do data processing for AI. To bring intelligent orchestration mechanism, by employing AI to the orchestration of data and compute resources, and also to support the optimization of the energy efficiency, how we can better handle the mainly the infrastructures that in a way that they optimizing the use of energy and we can make that computing it is overall more sustainable. So the overall aim for the call, it is to fund research that allow for optimal executions of services and data processing across diverse types of compute environments and network zones because of the prominence of the edge computing aspect, and also across various providers as it is typically in cloud. And you can move to next slide. So basically, you have here written down the text of the call that I guess you know well, but again, under this objective, our aim was to fund the seamless and trustworthy integration of diverse computing and data environments, as I was saying before, with the objective to ensure digital autonomy in Europe. Then to mix up, as I was saying before, the concept of computing continuum that we worked for years with the benefits that cognitive and AI could bring to this context, to this environment. So enriching the computing continuum with cognitive capabilities in order to enable significant enhancements. Moving next to the scope. So basically, in terms of scope, what we were looking at, it was to have AI-enabled management of the whole compute continuum, and making use of specific techniques like swarm computing or decentralized intelligence and others that could be equivalent to support the novel automated management tools, programming model, and learning and decision methods that are able to handle the resource heterogeneity, the extreme scale that it is expected specifically at the edge, and also to handle fault tolerance with the necessary elasticity and flexibility to allocate resources and tasks. Another element that we were looking at, it was how to bring intelligent compute data and code orchestration mechanism in order to extract from in an efficient manner value from the large volumes of data generated in the continuum, but also taking into account the dynamicity and the scalability of the resources that more and more we will be having present in the compute continuum. And last but not least, because it is a crucial topic as highlighted by Nick before, the optimization of the energy efficiency and the ecological sustainability, considering end-to-end data processing across the continuum. So if you move to next, please. Just a highlight from my side before we start. You are all, as Emiliano was saying, you are all funded projects and these objectives were published by us. At the same time, we have CSAs that are expected to establish the collaboration mechanism between you, all of you, and very recent, not that recently, but some months ago, Nexus Forum started its activities. It is expected to take over the EU Cloud Edge IoT forum that you have, or that I guess that you have been using so far. The Nexus Forum CSA is expected to bring all the collaboration means for you for projects, but also they are preparing a research roadmap. And for this, it could be very much of interest to count with your inputs from your projects and organizations perspective. And the group is, the project is expected to do this through the participation in working groups. So the coordinator of Nexus Forum already has your contacts, and probably you are already in contact. But in any case, I wanted to bring here the message. If you are not in contact, please get in contact with them, because the result of this research roadmap will be very helpful for us in order to define the upcoming programs. And also it is the mechanism for you that you have in place. If you have research areas that you think that should be included, that you would like to see more in the future, please factor this in the roadmap, so we are getting these insights from the research community. And I think this is all from my side. The next one is the name of the projects. I wish you have a very interesting workshop, and I will be there for the end if you have questions for us.
Great, thank you very much, Anna, and thank you, Emiliano, as well. That was fantastic. A really nice intro and the background to the projects which are being presented today. And of course, the project you just mentioned is very important in terms of, for all of these projects, in terms of collaboration and bringing such findings and recommendations to a broader audience. So that's great. Thank you for that, Anna. So with that, we'll introduce our first project. So I'll introduce Iakobos Michailidis from the Center of Research and Technology, Hellas. And Iakobos is going to introduce the HyperAI project. So Iakobos, you have 5 minutes, as each speaker has, and then of course you'll have the chance to answer questions in the Q&A. And I just wanted to add, sorry, Anna and Emiliano are very kindly staying on to the end of the webinar. So so we'll have the Q&A at the end, and they'll also be around. Okay, so okay, sorry. Now over to you, Iakobos.
Thank you, Nick. So about HyperAI, I'm the deputy project coordinator of the project from the Center for Research and Technology, Hellas. HyperAI is, let's say, a new project. We are month 6 right now, month 7 actually. We changed month. HyperAI is about, I mean, the architecture of HyperAI is shown on the right-hand side. It's layered, let's say, a stacked structure of our concept. What we aim to do is to impute cognition at the different levels of the computing continuum, enabling hyper-distributed management of its resources, especially focusing, as Anna mentioned before, on data-intensive applications. HyperAI aims to facilitate autonomous orchestration at different levels as centrally, minimizing the central approach actually, at cluster and at a POD level. We also have aspects, HyperAI also has aspects about distributed ledger technologies for the security of the communication security between the different nodes and the PODs. We also have aspects we intend to work on interoperability, especially focusing on ontologies and semantic representation, both for applications representation as well as for resources representation as well. And HyperAI, the use cases, the applications that we aim to host, let's say, in our, let's say, computing continuum are 5, spanning across different industrial sectors. And we also support open science. We have open science activities like community and open source, community building and open sourcing of our tools. Next slide, please. So these are the 5 use cases, as I mentioned before. One is about Industry 4. It's actually a remote AR-based production line assembly. The other one is related to green energy. It's about emergency response, emergency management in nuclear reactors, in a normal, let's say, situation for nuclear reactors. The third one is on mobility and automotive. The fourth one is on farming and agriculture. It's about edge orchestration for nutrition and irrigation management. And the last one is related to healthcare. It's prediction of emergency fauna and flora originating pandemics. Next slide, please. So about the project impact, it can be summarized, let's say, in 3 bullets. It's about improved European leadership in the global data economy, maximize social and economic benefits from wider and more effective use of data, and reinforced Europe's ability to address urgent societal challenges like crisis management and clean energy. Next slide, please. Now about the next, I mean, the upcoming, the next steps for the project. We are, as I already mentioned, we are in month 6. We are actually delivering the first deliverables of the project right now as we speak. It's about the next steps are about defining the architecture, the overall architecture, and the blueprint. Study the identified end user and business requirements. Also study community-driven relevant solution, open source actually, like Kubernetes. So where we fit and what we can, let's say, advance there. Start converging the development towards seamless prototyping and integration. Of course, we need to integrate our tools together and build, as today, build mutual synergies at technical and communication for technical developments and communication activities with sister cluster projects. And I think, next slide, please. I think that's it. Thank you.
Thank you very much, Yakuras. That was great. And of course, as we said, there'll be time for Q&A at the end of this session. So thanks very much, and thank you for keeping on time as well. So the next project next up is Intend, integrating human-like intelligence into cloud edge IoT computing. And I'm pleased to introduce Hui Song from Syntef, who'll give this presentation. Over to you, Hui.
Thanks a lot, Nick. So we'll present the Intend. You can see the partners with the logos in this slide, in the bottom of the slide. We have a team with a good mix of universities, research institutes, large enterprise, and SMEs. And I'd like to mention that we also have 3 partners from South Korea to exploit their advantage on AI and semiconductor. Would you please move to the next slide? The objective of Intend is to investigate how we can improve the automation of managing the data operation and their use of resources in the cloud edge computing continuum. And we want to push the boundary and to see to what extent we can replace the human forces in this time-consuming task by AI agents. So we don't want to introduce some tools that can help us to manage the computing continuum, but instead we want some agents that can, to some extent, make their decisions to replace the hard job for human. And to do this, we need the agents to have some kind of human-like intelligence. So we break down this into 3 key properties. They need to adapt like human. If there's new resources, new type of devices, they should be able to learn how to use them. They need also to think like a human in a strategic way. So if the continuum is a composition of distributed and decentralized groups of resources, they need to coordinate the decisions that they made on the different parts. And last but not least, they need to be able to talk to human. So we should not, or the stakeholders should not tell them how to manage the continuum step by step. Instead, there should be a way that the human and the agent can share their intents, so the continuum could manage the system according to the human intents. So next slide, please. Yes. So the architecture, a little bit, could you go back 1 slide more? Yes, this one. So the architecture, we start with the resource management tools from intent-based style. So we have intent-based management for our intent-based orchestration, intent-based networking or network management, storage management, and also how to manage the neural computing resources. And based on that, we have the decentralized intelligence to coordinate the decisions. And finally, we introduce generative AI to help stakeholders make some high-level decisions, and also to allow the stakeholders to talk to the entire system via natural language. So without going much into the detail, I can show our use cases in the next slide, please. Our first use case is about the green media streaming, looking at using this intent and intelligent management, how much resource we can save for the media streaming industry. And next use case is about how to allow the non-technical workers to talk to the machine continuum to manage how to analyze the data from machines. And next slide, please. The other two use cases are about first how to use the 5G infrastructure as also a data operating infrastructure. And to do this, we need to allow the infrastructure to understand how the different application providers intend to use the resources in the continuum with both networking and computing resources. And the last use case is about providing the platform for the urban data space, which can understand the different intents from data consumers and data providers. So next slide, please. We aim at provide in total 11 open source tools, which combine together into a platform with a new hardware and AI models for managing the computing continuum. And this will cover the entire supply chain. And with these results, we aim at providing new ways to manage data pipelines and their resource usage. Yep, I can go quickly. The next next stage, we will focus on providing key proof of concept prototypes and integrate the tools with the minimal valuable scenarios from all the use cases. Thanks a lot.
Okay, great. Thank you very much, Rui. Thanks for that. And you'll be in the panel later on as well. So let's jump to the next project, which is EMPYREAN, enabling hyper-distributed computing via IoT federations. And I'm pleased to introduce Panagiotis Kokinos from National Technology University of Athens. So over to you, Panagiotis.
Yes, hello all. This is EMPYREAN project. I am a part of the coordinator team from the ICCS and TUA. Can you move to the next slide, please? Yeah, so EMPYREAN is about envisions a collaborative autonomous computing ecosystem that contains heterogeneous resources from different owners, from different providers, from different users, supporting various connectivity means, so that the basic idea of EMPYREAN is to build what we call associations, which is collections, federations of these resources, not only computing and storage resources, but also IoT devices, robots, drones, whatever. So having these entities, which are the associations, which are autonomous, let's say, edge, IoT edge continuums. And each association is by itself a secure execution environment where users and workload can be executed in a secure manner. And also, of course, we envision operations that also involve inter-association operations. So we say that we will not only have operations inside an association, but also inter-association operations. And so we say that we transform this IoT edge cloud continuum to an association-based continuum. That in practice involves multiple IoT edge cloud continuums. Can you move to the next? And in this figure, we see these associations. Yeah, in this figure, we see these different associations consisting with different components, different resources, and the existing and the logic. Next slide, please. So we have 3 use cases. All the use cases in practice involve robots that do some operation in different environments. and they want to make some analysis, and they use they form associations, and they use EMPYREAN developments to make this the storage, the respective computations. Most of them relate to AI ML workloads. So we have an advanced manufacturing use case that we have a robotic machining cell that monitors its operations. That we have monitors on the robotic cell, and the EMPYREAN is used to send workload. We have again a smart agriculture use case where we want to develop a process for analyzing the soil. And again, we have robots that are moving, either drones or tractors that are moving in the field, collect information and use the EMPYREAN platform and the associations formed to make the analysis. And again, we have a warehouse automation use case where we have a fleet of robots, so small robots that are used to carry boxes and stuff like that. And we create associations, and we have the EMPYREAN to help the operation of the robots. Some of the operations, for example, is to analyze what the camera of the robot sees, so as to help the robot move correctly or grab correctly or identify which object is which. Next slide, please. About the impact, of course, we envision that through this association concept, the EMPYREAN association, will make possible for European entities to make better decisions about their processing and storage of data. Since this association is an entity by its own, it's an EOTH cloud, let's say, entity by its own, we say that European entities, organizations, users will be able to have better power on their hands about how they will use and their resources or process their data. And also through the developments, we expect that we will help realizing Europe's digital industry-related targets. We also promote software interoperability following standardized interfaces. We use open source components, we extend open source components, or we develop open source components. And of course, we expect EMPYREAN developments to help strengthen European position in the edge, cloud, AI, ML sectors. And about the developments in the next period, EMPYREAN is in month 8 at this time. We have completed the initial phase of the architecture of the EMPYREAN platform, and now we are starting development activities and actually integration activities, since we have some components that are operate and we can integrate them and extend them in parallel in all these direction, in security, in storage, in EOTH interconnection, in workload execution, in cognitive operation, in energy-aware orchestration. So we are in the process of developing, integrating our works. Thank you very much.
Thank you very much, Panagiotis. Sorry for my pronunciation. And that was really interesting. It's really interesting to hear that how the different technologies will be applied in different use cases, and there's the concept of them grabbing boxes, and is really very practical, and you can see how this would have real impact in a real place. So thank you very much, Panagiotis. And now I hand over to the ENACT project and Alessandros Nizamis from the Center of Research and Technology, Hellas, for the ENACT project is enhancing resource management with AI and dynamic graph models. So over to you, Alexandros. Thank you.
Okay, hello. As you said, I'm Alexandros Nizamis from Center of Research and Technology, Hellas, that is coordinating the ENACT project. In this project, we're aiming to create a framework to support both the adaptive scheduling and the deployment of data-intensive workloads in cognitive compute continuum. So in next slide, we can see how we're trying to address some of the major challenges in the cloud edge orchestration and which are our main objectives here. So we're trying to conduct some research and introduce some cutting-edge solutions for various parts in the cloud edge continuum. So we are starting from the part related to the discovery and the connection of distributed resources by providing modeling of these resources and try to support the complex application deployment needs. After that, we have the AI part that we are trying to provide the optimal load balancing in the compute continuum and the best possible orchestration by combining various AI techniques such as GNNs by representing the whole continuum like that and DRL agents to optimize the whole procedure. And after that, we have our application programming model and a connected SDK to it that will support us for developing our kind of self-managed applications that can be configurable in the various cases in the cloud in this compute continuum and try to offload also some workload from the orchestrator itself. Our use cases are listed in the next slide, so please, okay. We have 3 use cases in this project. The first one is about hyper-distributed data processing for Fujitsu's mobility digital twin. So we try to provide some decentralized processing now as they are facing the challenge of continuously collecting more and more data. So they need to try to see how it's possible in a compute continuum to offload some of this workload from cloud to some of the edge of fog resources. After that, we have the second pilot that is related to distributed media and entertainment content management. In this pilot case, where the focus is to try to improve the experience of the audience in a live events such as a football game, etc. So we need to annotate data on live time and do some parallel processing, etc., etc. So to be faster on this process. And the last pilot is related to the production and distribution of media content. It's mainly it's related to tourism sector, and we're focusing on how we distribute advertisement material and so on related to a rowing game that will take place in Spain. Now regarding the project impact. First of all, we're trying to support some common standards and infrastructure in Europe related both on computing continuum and data spaces technologies. For example, we have seen all these big initiatives such as Simple and how we can also support on that and work on some parallel developments here. We're trying also to promote the more effective and use of data processed across the continuum, and this will be can enable its application in different kind of domains. Also, we're trying to design some an energy-aware data infrastructure, and try to reduce, of course, the footprint of this CO2 footprint of this infrastructure by promoting decentralized, intelligent, and application execution on the edge. And of course, as I think a common target of all this project on this cluster is to try to shift a bit the market from non-EU entities related to compute continuum, as mainly now USA and Asia dominates this area, to bring it more to Europe, European part, and try to enlarge this part. And I think for the end, we have our next steps project. So what we're doing right now is, after creating the first version of architecture and specifications, to try to finish them. Also, after that, we try to do some further developments regarding some AI parts. We have also to start now our pilot-related activities. We have defined our use cases, but now it's time to start the actual tasks of the pilot activities and see how the initial prototypes that we have created on some public data sets or on some testbeds that we have developed in the project can be applied also in the pilots. Also, we need to set up our secure data space to be used as a kind of distributed storage in the project and try to exchange data across the continuum based on that. And of course, to further support the dissemination activities and this clustering that we have started by the beginning of this whole topic, and to continue all these activities with all of you here. I think that's it for me. So thank you.
Thank you, Alexandros. That was great. It's good to hear you mention the SMEs and deployments beyond the project lifetime as well. So this is an interesting thing that we'll probably pick up in the Q&A, because of course, in the grand scheme of things, this research can really play an important part within Europe and within keeping digital sovereignty in Europe. And you mentioned, increasing influence of Europe over other areas of the world. So thank you for that, Alexandros. Now we'll turn to MYRTUS, enhancing CPS through edge, fog, and cloud integration. And I'm pleased to welcome Francesca Palumbo from Cagliari University, beautiful part of Italy.
Yeah.
And over to you, Francesca. Thank you.
Hello, everyone. First of all, let me thank you. I cannot see myself. Is it normal? You see myself? You see me, right?
Yes. Yeah, we can see you. Yeah.
Okay. So thanks a lot for having organized this webinar and for having invited us. I am the scientific coordinator of the MYRTUS project. MYRTUS stands for Multi-Layer 360 Degrees Dynamic Orchestration and Interoperable Design Environment for a Compute Continuum System. Next slide, please. And the goal is, the primary goal, I would say, is to create and provide efficient computing continuum management, leveraging advanced technologies. Especially, we are working in particular on the usage of federated learning strategies and swarm intelligence technique to do this orchestration. The project is based on 3 main technical pillars that are summarized in these slides, but go to the next, please, and that I will present more in details now. The first one is the definition of a reference infrastructure, where a diversity of fog, edge, and cloud form a computing continuum to respond to the needs of complex dynamic systems. At the edge, we leverage advanced embedded system, including heterogeneous system on chip and RISC-V cores, and we make these devices cooperating with fog layer devices. So we have 2 kinds of devices. Some of them are
I think we lost Francesca. I think she's left, if I'm not wrong. So while Francesca gets back in, let's go quickly to the next presentation, and we'll come back to Francesca. Okay. So Tamas, I hope you're there, from the University of Westminster, and Swarmchestrate, that's a great title, introducing self-organizing swarms for edge and fog computing. Tamas, are you there?
I am here. I just have problems unmuting my video. So yeah, now it is.
Okay, great, excellent. Okay, thanks, Tamas, for jumping in there.
Okay, so thank you very much. I would like to introduce this Swarmchestrate project. Swarmchestrate stands for Application Level Swarm-Based Orchestration across the Cloud-to-Edge Continuum, and I'm Tamas Kiss from the University of Westminster and the scientific coordinator of this particular project. So next slide, please. Yeah, thank you. So Swarmchestrate is, as it was explained before, part of this particular cluster. We started relatively recently, as most of the other projects of the cluster, probably a few months earlier. So we kicked out on the 1st of January 2024 and running for 3 years. We have 14 project partners from Europe, but also including 2 UK partners and a South Korean partner. So our funding is coming, the majority is coming from the European Commission, but significant part is coming from UKRI and South Korea for this particular project. We are a good combination of academic and industry partners. Industry partners are especially involved in the use cases, but also in the development of some of the core technologies. And the project is officially coordinated from Hungary, but as I said, the scientific coordination is with the University of Westminster in the UK. So next slide, please. The project idea or what we would like to achieve in the project is very similar to some of the other projects. We would like to develop a completely decentralized orchestration solution. And an orchestration solution, we mean an automated deployment and runtime management solution, which is fully decentralized. There is no central level of control, and which manages, kind of self-manages the application components. So we base this idea on swarm computing and the ideas of the self-organization of swarms and decentralized blockchain-based knowledge management solutions, which are providing all the necessary information for the swarms in order to create themselves, in order to generate themselves and reformulate their operation and their composition during the runtime of the project. So the idea is that we have an application owned by the application owner, an application developer, which is described in a standardized Tosca-based description format, submitted into this decentralized interface, and then swarms are forming automatically based on knowledge from a decentralized and distributed knowledge base in order to complete these particular tasks. So if you go to the next slide, I would like to talk a few words about the project's use cases. We have currently 3 use cases. We started with 4, but with some, because of some administrative issues, we needed to unfortunately not include one of the use cases at the very beginning of the project, and we are currently in the process of incorporating a new use case. I did not want to include that in the slides because they not officially joined the project yet. So our use cases are, what is common in the use cases is that there are a very large number of distributed sensors which are collecting information at the edges of the network, which then needs to be processed in various levels of the cloud-to-edge compute continuum. So these use cases are focusing on flood prevention with a network of sensors in the city of Athens and trying to predict when a sudden flood event is going to happen. The second one is about parking space management, where again, sensors are controlling the free parking spaces and providing information. And the third current use case is about a digital twin of the natural habitat, where again, we have a very large number of sensors placed in natural environments. We are collecting information and we are making decisions and running applications based on that. The fourth use case we are currently in the process of including is a use case in a city environment where cameras and other noise and sensors are collecting information and being processed. If we go to the next slide, which is about project impact. So the idea of the project is to optimize the deployment and execution of hyper-distributed applications with a generic decentralized orchestration framework. So this generic orchestration framework is the one which we are developing, and then proving the impact of this in various application areas. And the use cases are just kind of representative examples because the framework is completely generic and can be used in other application scenarios. So we optimize quality of service requirements, reduce energy consumption, reduce costs of operation. And as I said, we are demonstrating how these are actually materializing in the selected use cases. And then if you go to the last part of the presentation, to the next slide. What we are currently doing is that we are completing the design of the orchestration solution, at least partially, or part of the orchestrator. And we are implementing a first prototype solution, which will be ready by the end of this year. This prototype will focus on the deployment process. So we are, at the moment, simplifying the problem and not dealing directly with the runtime orchestration, but we are focusing on the automated deployment of the applications in this cloud-to-edge continuum in the most efficient way. And then we are going to align it into the demonstrators and implement the first version of the demonstrators based on the central generic orchestration solution. So with this one, I would like to go to the next slide, and I would like to thank for your attention.
That's great, Thomas. Thank you very much. And yeah, it's very interesting. You mentioned, you know, the energy consumption, the reduction of cost of operations, and improving efficiency, which are things we'll also discuss in the panel. So, Francesca, you are back online. I hope you're okay. And you were about to tell us about the reference infrastructure from the MYRTUS project. Are you okay, Francesca? Can you hear us? Oh, I think we lost Francesca again. Okay, she did appear. So let's go then to COGNET. Sorry, Diego, you've got to go forward on the slides again. So COGNET, and I'd happy to introduce Georgios Spanos from the Center of Research and Technology, Hellas. And COGNET is integration of edge, fog and cloud computing. So Georgios, over to you.
Thank you very much, Nick. I'm Georgios Spanos from Center for Research and Technology, Hellas, which coordinates the COGNET project. I would like to start, please, Nick. Yeah, yes. The main aim of COGNET is to develop a middleware framework that is able to empower the whole continuum, IoT, edge, and cloud devices, in order to organizing swarm continuous This could also enable operation of continuum with no fixed orientation, and we would like to shift to a non-demanding opportunistic approach, targeting to dynamic swarm continuums. This also will promote the self-organization. The project will promote the self-organization and the collaborative learning of various devices by introducing a new branch of AI, the asymmetric multiplayer competitive games, that containing the self-organization of pricing, bidding, and auctioning properties. So our concept is to fuse such game logic within each individual device and turn it into a cognitive resource that is capable to self-realizing, or in terminology of the game's pricing, each onboard data and resources, to self-organizing, or in this terminology, bidding, and finally, if and how to utilize in the common computing spaces, or auctioning, as we say, subject to the service request. So the final outcome is the swarm continuums can be formed dynamically, not fixed, as a result of this game that will be running as a decentralized optimization process in order to find the precise computing equilibriums, which are the golden states. Okay, let's go to the next slide. Okay, there is no, please, to the previous one more. Okay, these games are also designed in order to consider additional heterogeneity dynamics related to cyber risk, energy consumption, and system faults. And we will see also in the discussion later, one of our main novelties is the consideration of KPIs considering both security, computing, and energy. So if we can go to the schema, please. Yes. So in this graph, we can see the concept of COGNETs, devices acting as autonomous game players, and we can see in the three use cases that I will present later that we have different situations and how these three KPIs, computing, energy, and security, are distributed differently according to no incident situation or during traffic jam or during medical emergency. Let's go to the next slide, please. Okay. We have three main use cases in our project. The first is about Industry 4.0 manufacturing. We have the connected factories. The three objectives of this use case is the first objective is the autonomous precision control optimization. The second one is about the predictive maintenance. And the third one is about the condition-based service monitoring. And we can see in the right upper corner the Industry 4 use case, which will be based in Germany, with Siemens be the main actor in this use case. For the second one, it's about connected vehicles. The three objectives are the data-driven control strategies, the predictive maintenance also, and the condition-based service monitoring. We can see in this in the right side that the AVL will be the main actor, and we plan to have the battery electric vehicles in this use case. Finally, the last use case is about health, connected healthcare, in order to achieve assisted diagnostic and medical data analytics, secure hospital and home care prevention, and finally, the next generation telehealth service. And as we can see in this use case, we will have a virtual hospital, serve our site, and Hellenic Mediterranean University will be the leaders of this pilot. And we can now go to the next slide. Yes. And this is the three previous use cases are the first stage demos, as we are saying in our product. We have also a second stage demo where we combine the three use cases and we introduce a new factor in this approach. We have the information sharing, and it is that I displayed in the introduction with the different situations and how the devices can beat the resources, and in different situations how they behave. Okay. Okay, this is about the impact. We cover all the different aspects of impact, starting with the strategic impact. We are in line to the objectives of EU strategic foresight, the EU strategy for data, and the digital agenda for Europe strategies. Regarding economic impact, we aim to deliver business-friendly software tools and best practices for efficient and secure data processing. And with this way, we can boost EU strategies and SMEs competing in key economic sectors. Regarding scientific impact, we aim to enhance the capacity of EU innovation, since we try to innovate in the areas of IT, artificial intelligence, ICT, robotics, and cybersecurity. And finally, regarding the social impact, our technology will directly improve the digital application of EU citizens, and also ensuring highly computing efficient data. And the
Great,
last,
thanks, George. I think I'm going to have to cut you there unless you've got something really quick to add. Okay, go.
Yes, of course. It's one slide. I think it's the last one. Okay, please, yes. We have COGNETs is the newest project. We are in the design phase now. In order to select technologies and design the architecture, we are also in the start of the development phase to develop the intelligent game agent and the collaborative federated learning mechanisms. And of course, the communication dissemination activities are active. We participate in different events. We are planning scientific publication, etc. Thank you.
Great, thanks very much, George.
And sorry for the delay.
That's okay. That's okay. That's fine. We have Francesca, I think,
Let's
back
try that
online.
again.
So should we
Sorry
try
about
again?
it.
That's okay. That's okay. I know you're having difficulty with connections in Cagliari, so that's okay. If we go back, and if you could be quite quick because we're running.
Yeah.
Thank you very much, Francesca.
Yeah, sorry. I was describing the three technical pillars. As I was saying, the first technical pillar is related to the reference infrastructure creation. And we have we are working a lot at the edge on improving multiprocessor system on chip and RISC-V processor to work on open architectures. And these edge devices will cooperate with some fog devices with different characteristics. We range from simple bridges to complete micro data centers infrastructures. And all of these connects to the cloud for storage and non-strict real-time, of course, computing task. Next slide, please. This complex infrastructure is meant to be orchestrated, managed by our MYRTU cognitive engine. MYRTU stands for multi-layer dynamic runtime orchestration, and its goal is to achieve runtime adaptivity between layers and within each single layer. Resources are going to be monitored, and runtime orchestration is going to be put in place to achieve a continuous optimization of the performance, of the energy efficiency, while being able to guarantee security and trust. To do this, we are going to use, as I mentioned before, AI strategies to master the loads as well as to master the loads distribution and redistribution and the configuration of the individual single resources. Next slide, please. Such a complex infrastructure, the design of the complex infrastructure, as well as the inference of the runtime cognitive engine needs the definition of a reference design and environment to facilitate designers' life in these complex scenarios. The design environment and programming environment that we are working on features interoperable supports for cross-layer modeling, threat analysis, design space exploration, customization of the single node at the edge, and also code generation. Next slide, please. We are going to assess all these pillars and all our MYRTUS technologies on two different use cases, the smart mobility one and the virtual telerehabilitation scenarios. In both cases, we have as request low latency response and the management and orchestration of an highly distributed plethora of sensing, computing, and actuation elements. In the first case, the mobility one, we are talking about the orchestration of cognitive connected cams, while in the second, we are dealing with a multi-user virtual reality environment where collaborative rehabilitation tasks are carried out with active feedback at home, so in a completely distributed manner. Next slide, please. We expect to achieve wide impact at the end of the project, and we have already started to establish contact with relevant communities and projects. like the activities today. We published different papers and presented our technologies also in the form of tutorials in various international events. In the next few months, the goal is to push more these synergic actions because we have completed the requirements definition and we are starting the development of the technologies, and we don't want to diverge, that this technology will diverge from the current trends around us. Next slide, please. As I said, you can go directly to to this one. And in terms of timeline, we are at month 10. We have completed the technical specification of the projects, and we are now working on the definition of the different interfaces between the technical pillar, starting the developments of the individual components, their integration and assessment within the use case. And as said, we are going to have a first review of our technical activities in May, June next year. And so the synergic actions we have planned are meant to gather the feedback on the initial deployment, on the developments. And this concludes my brief presentation.
Francesca, thank you very much. That was really interesting. And what a slide you had on the impact. That was really nice, showing the different organizations, different industry and also the standards organizations as well, which was very interesting. Okay, so I'd like to ask all of our panelists now to turn on their cameras again, because we're going to go into the panel discussion now. If you have any questions, then please pop them in the Q&A box and we'll try to get them. We've heard a lot in all of the presentations, which were, I think, really interesting, all of the different ways in which the projects are applying these technologies to different vertical sectors in particular was interesting, and really how this can facilitate and increase efficiency while considering security as well. And this is where the first question comes. So the first question to you all is around the technologies under the development. So we're interested in which of the key technologies which will foster and ensure security, which of course means trust in these types of solutions for eventual market uptake further down the line. Efficiency. So here I think, thinking of how things will improve efficiency, which of course could lead to financial impact as well on an organization or a company adopting these technologies. And then scalability. So how realistic and how possible, and which technologies are key for rolling these applications out and scaling them up at a broader level to give Europe and European companies and organizations greater advantage. So I think it would be nice if I can give you a minute each, okay? And if we could go back to Jakobos from HyperAI. So we'll go back to the first speaker and just give you a minute on that question. Perhaps you want to elaborate on one of those things. So security, efficiency, and scalability.
So thank you, Nick. About HyperAI, at least, this is where I can, let's say, chip in. About HyperAI, we intend to work with distributed ledger technologies, which are actually distributed, as the name is from the name it's evident. So using a distributed approach for tracing and authenticating transactions between different sections or parts, or let's say clusters and PODs of the cloud continuum, we try to ensure intrusion detection using DLD technologies, and distributed technologies in principle, let's say, are scalable and more efficient in terms of the needed resources that they need, let's say, to be executed on. That's it, Nick.
Thank you, Jakobos. was unmuting myself. Great, Yakos. Thank you very much. So yeah, very important, and of course the security aspect in terms of intrusion is of course key to that and key to building trust. So I put the same question to Hui as well from the Intend project.
Yeah, security is not the main objective of Intend, so it's one of the tasks. And for us, we focus on mainly the explainability. So we want to know if the data pipelines use certain resources, and each of these resource providers may offer several choices for the security mechanisms. And we want to explain to the operators what are these choices, what are the risks by going with or without one of these security mechanisms, and what would be the security or trustworthiness level if you combine some of these. So it's more about providing a guidance to the operators. So yeah, we don't directly address security.
That's fine, though, but you do support the operators themselves, and clearly by reducing the burden on them to make decisions, you make it, you facilitate their lives, basically. So of course, I'd imagine that would be a key thing in a decision maker adopting these technologies.
Yeah.
Okay, thank you. So if I go now to Panagiotis, the same question.
Yeah.
So okay, over to you.
Overall, two comments. In EMPYREAN project, we have developments that address both security using secure storage, using blockchain. We address resiliency, having multiple associations. So we have technologies that we try to address in multiple layers all these aspects. And my other comment is that overall, I suppose, though I haven't seen all projects in detail, I suppose we have similarities in the technology that we employ. The one aspect that we suppose is also important is to check, how these developments can in practice be embodied in software, in devices, or embodied in the way we organize providers or companies use the resources. So one aspect is the technological one, and I think the other aspect is the organizational one, how this can be in practice be employed in real life scenarios. That's all.
Great, thank you. Yeah, and I suppose the more experience you get, and more success and impact that you create in the different sectors, the more trust will be built into the adopting these solutions. And I suppose I wonder how ready organizations and companies across Europe are for eventual uptake of these technologies. Is the market ready for this? Is the trust there as well? So we can also consider that in our questions. So Francesca, I'll go to you as well. Same question. Yep. On the security, efficiency, and scalability, or you could focus just on one of these.
Yeah, efficiency and scalability are at the core of the MYRTUS cognitive engine development, but I want to spend some words on security aspects. We are dealing with the security both at design time and runtime. At design time, at the modeling level, we have a component of our design and programming environment that basically is responsible of threat modeling and countermeasures planning. As an advance of the state of the art in this field, we want to build automated countermeasure design, meaning that we want to automatically synthesize this countermeasure at the code level, and also to plan some the configuration of the infrastructure where possible to help designers to have more secure environments for their applications. Indeed, at design time, this threat modeling will also define some metrics and monitors to be included in our MYRTUS compliant infrastructure, to be used at runtime by MYRTO, to be able to switch and reconfigure from one deployment to another, to make, for example, to increase the level of security where needed. So security is among our drivers, not just scalability.
Great, thank you very much. Yes, and of course, an attack on any company is can ruin, you know, reputation, etc., and future business, of course. If we go now to Tamas, so again, security, efficiency, and scalability.
Yes, so obviously each of these three are the core of the orchestrator which we are developing, and these are absolutely the focus of our work. Scalability and efficiency are by nature it is, because what we are doing is that we are real-time monitoring the applications and immediately reacting on certain quality of service violations. So, for example, if the application consumes too much energy, if it is not providing a response by the deadline, if the resources are not providing reliable information back, then we immediately reconfigure, or the swarms are kind of self-configuring themselves in order to fulfill these requirements. And on the security front, we are very much relying on and implementing solutions for trust. So we use decentralized identifiers, we use blockchain technology in order to assure trust and reliability. And we also use cryptographic solutions, novel cryptographic solutions, to provide, for example, privacy-preserving data analytics. So we encrypt the data, and then we do a ranking algorithm, for example, in the AI solutions, without ever decrypting the data. And we use these specific encryption methods, for example, functional encryption, in order to achieve this. So this is innovation.
Thank you very much. Yes, it's very innovative. And our screen has gone orange, I can see. It's also very innovative. So I can pass the same question to Georgios as well. Georgios, again, to you, scalability, efficiency, and security.
Yes. As I said in my introduction for the COGNETs project, the main approach, the main concept of this project relies on the intelligent game agents. These game agents are supported by this new approach of KPIs that can consider computing versus energy versus security KPIs, this multiple optimization problem. So the main approach for the Cognet is to consider all these aspects together in order to optimize and go to this golden state, as I said in my introduction. Regarding also the efficiency, we are applying the collaborative federated learning mechanisms toward optimization and rapid service and rapid services. And also for the security specifically, one of our objectives is the end-to-end security. And we are trying to cover this end-to-end security by 4 different pillars. The first one is the swarm-centric threats. We consider swarm-centric threats. We also approach the security issue with also considering the AI-based security with adversarial shielding. And also we are using decentralized technologies, the third one. And the final one aspect of this security is regarding the hardware security. And we approach this issue with the RISC-V hardware. Very briefly, these are our main technologies for this for the Cognitive project. That's for me.
Okay, thanks, Georgios. Anna, if you have anything to add, you'd like to add anything, then please do jump in or
Sorry, Nick, I can give you also
Alexandros.
the ENACT
Yes,
approach on this?
Yes, I'm terribly sorry. Sorry, of course. Yes,
No worries. Okay, so now regarding ENACT, about security, we are trying to add it in various parts of compute continuum. For example, and using various technologies, we have a zero-touch provisioning adoption here, not only to automate the configuration and deployment of new nodes or devices in the continuum, but also to support the authentication of the devices enrollments and also the secure communication using encryption. We're using a common identity and access management framework for user and roles across the compute continuum. And also we have adapted the data spaces approach by using some connectors for secure, trusted and sovereign data transmission in the compute continuum. Regarding the efficiency now, we have our AI layer with this DRL and GNN combination that we're trying to optimize the task scheduling and also to the workload distribution. So this will support to have more execution also on edge, aiming to reduce latency, but with the users, etc., etc. And the last part is kind of scalability, I think. So what we're doing is set up this graph-based modeler that we have for adding more and more nodes in our continuum in a common way, and also by adapting a kind of microservices and containerization-based architecture that can help us to have some faster deployments and scaling across the compute continuum. So this is some high-level approach how we're trying to tackle with all these three core needs in this project.
Thank you, Alexandros, and apologies, I skipped you
worries.
earlier. Okay, Anna, if you have anything to add, you can.
Sure, anytime, but for the time being, nothing specifically. Thank you very much to the project for the interesting presentation.
Okay, great, thanks. So I'm actually going to go. There's a question. I'm not sure if maybe not everybody needs to answer this. There's a couple of questions around swarm computing have come up in the chat. I think the Melanie Schrantz and Dave Raggett, and perhaps we could take Melanie's, which I think they're pretty related, but it's most projects use swarm computing. But what is the specific swarm intelligence you're using in your computing continuum? Don't know if anyone's able to give a quick answer on that. If anyone would like to.
Nick, I could start with, again, just to follow the same, let's say, order. If I may, I mean, in our case for Hyper AI, what we do consider actually about the intelligence and the self-configuring of clusters and self-managing of PODs across different levels of the continuum. We intend to work with multi-agent reinforcement learning approaches. So different agents are partially aware of the full state of the system. So they are self-coordinating and create synergies with each other on using AIs. Local AIs in order to, let's say, swarm themselves and impute actually cognition in the full continuum, the full stack of the computing continuum.
Okay, thank you. Would anyone else like to pick up on this?
I may try. Okay. It's strange for me answering it to Melanie's question because Melanie is part of the MYRTUS project. But in general, what I want to say is that we are going to use swarm intelligence to arrange the reallocation of the pods, both at the fog level and at the edge levels. And what we are doing is leveraging on a tool that is called Frevo. It's a tool from Lakeside Lab that will allow us to characterize the swarm agents at design time, and then trying a different type of approaches in order to synthesize an agent capable of implementing then swarm approaches at runtime. And these swarm agents will be part of the MYRTUS cognitive engine. So depending on the actual metrics, gathered metrics, it will take decision on point-to-point reallocation at fog and at edge. We are not obviously going to use it at the cloud level where more centralized approach are going to be used.
Thanks, Francesca. Thank you. And anyone else on this point?
Yeah, I can chip in with this Swarmchestrate view of that. So practically, our idea is to use swarm computing to completely decentralize the orchestration solution. At the moment, everything in every orchestrator is very much centralized and managed centrally. And in our view, each of the applications in our space will be a swarm. So every single application which consists of a large number of microservices potentially distributed along the cloud-to-edge continuum will be one swarm. And these swarms are interconnected or interacting with each other in order to optimize, self-optimize their application execution. So that is the kind of idea that we use swarm principles in order to create a self-organizing ecosystem where each application is organizing itself, but also to a certain extent aware of the behavior of the other applications, which may influence the behavior of that particular application.
Great, thanks, Thomas. Yes, total decentralization is clearly important here. Panagiotis, I see your hand raised.
Yeah, just one comment regarding EMPYREAN. In practice, we do not have consider specifically swarm aspects. We have, since our use cases have robots, one aspect that we consider is how robots, though our use case have a few number of robot seats, how devices, IoT device or robot can onboard or offboard the continuum. So we develop both authentication, authorization technologies, and other aspects for how these devices can enter and leave, participate and then unparticipate from the continuum, and how they can use it, and under which principles can use resources or which resources, etc.
Panagiotis, just a curiosity, because in your project you refer to this concept of associations. Have you checked how it maps to the swarms concept that many other projects are using? Because to me, the way you were describing this in 2 slides, so the degree of detail is really low, but to me, it did not sound to anything as a concept different to what it is called sometimes swarm.
Yes, in terms of what we call associations, which are the different entities, there are mechanisms, and there will be mechanisms developed for the coordination of the intercoordination of the association. So there are aspects of the swarm, but yeah, we did not specifically consider. But of course, there are connections, since we have multiple associations that cooperate. Yes, of course, we will develop swarm-related techniques. But yeah, we do not specifically mention.
You don't refer to them as swarms, but you have developed your own concept. This is my understanding. Huh?
Yeah, it is a similar concept of yeah, it's a similar, and also about the term swarm also refers to the devices. So it's not only the computing aids, the IoT devices that can be swarm, can be robots, can be drones that are swarm. So there are aspects there that we.
In fact, there is no standard definition, isn't it? So I have seen works talking about swarms, including multi-cloud, edge, static edge, mobile edge. So in this way, devices, robots, drones, this kind of things. So the thing is, there is no a standard definition of what it is or is not swarm computing. There is research work associated to it, isn't it?
Yes.
But clear, thank you.
Thank
you. Okay, so if I don't know if Uri or Georgios or Alexandros wanted to add anything. If not, that's fine.
Okay, just one word from. Please, Alexander.
No, I don't have to add something more on that regarding Swarm. Also, our project is not that focused on Swarm, it's more like cloud edge thing here. So I think I cannot elaborate more on that.
Just one word from our side regarding COGNETs. I think this concept of swarm computing is more clear regarding the infrastructure sharing between different these cross verticals. Between manufacturing, health, and mobility, and how the concept of multiplayer asymmetric multiplayer games are fused in the devices in order to cooperate this only. Thank you.
Okay, great. That's fantastic. Thank you very much. And with that, I'm afraid our time is up. We did have a question about standardization and one about impact on climate of these technologies. And a few of you have mentioned standards, and a few of you mentioned, reducing climate impact in your presentations. But I'm pleased to say that we will be organizing another webinar with these projects in the future, so we can perhaps pick up on these topics then. We hope to do this in the new year, between February and March, because this collaboration between the 7 projects is something which is, something which will go on in the long term. And it's very interesting to see a point from Enrique, who, sorry, I'll not try to pronounce your surname, who mentions the Nexus Forum project again, and also the fact that the projects in particular with South Korean partners is of interest. So the speakers should have a look at that point in the Q&A. So clearly, collaboration with Nexus Forum, coordination and support action, and continued collaboration between all the projects in terms of looking at different areas where sharing knowledge and sharing experiences of the application of these different technologies and expectations. I think expectations with the different sectors that you're working with in the use cases is interesting as well, and something which was interesting that we looked at in the EU IoT Cloud Edge activity in terms of market readiness for these types of applications. So with that, I'd like to thank all of our speakers, Emiliano and Anna from the European Commission, Francesca, Uri, Yakovos, where's my list? Panagiotis, Tamas, Georgios, and Alexandros. Thank you very much, everybody. And thank you also to Diego Simoni and Alexandra Burchill for organising everything in the background. So with that, thank you very much, and we'll see you for the second webinar. And Panagiotis, we'll see you for the next webinar in the new year. Thank you very much, and goodbye.
Thank you. Bye.
Thank you, Nick.
Bye. Thank
you
you
all.
very much
Bye.
to all.
Thank you. Bye.
Bye.